The world's thirst for oil and gas seems insatiable, but dwindling supplies are pushing companies to drill ever deeper and ever faster. Can massive oil rigs survive monster storms to find the fuel? And can mega shipyards build the new rigs fast enough to keep pace with exploding demand? The world is desperate for energy. Every day we consume more than 80 million barrels of oil and more than 7 billion cubic meters of natural gas. But oil and gas are getting harder to find, and new discoveries are smaller than they used to be. It's a crisis, and it's forcing energy companies to search in some of the most treacherous places on the planet. Like the North Sea. A patch of rotten weather that lies between the British Isles and Scandinavia. For thousands of years, the North Sea has been feared for its storms. Here, 25-meter waves have been measured. So drilling for oil or natural gas here is nearly impossible. But buried beneath the North Sea are 15 billion barrels of oil and 5 trillion cubic meters of natural gas, so it's worth any sacrifice to go after it. And to get to those reserves, it takes a mega-structure oil rig. A rig like this one, the Noble Pete. This 9,700-ton monster can drill wells more than 7 kilometers beneath the sea floor. Its heavily reinforced hull and legs are designed especially for harsh environments like this. Every bit of this armor is needed, because this corner of the Atlantic is literally a killer. Since 1980, more than 350 North Sea oil and gas workers have lost their lives.
Explosion and fire on the Piper platform.
It's a grim statistic every rig worker knows. Like these guys, suiting up for their next 2-week shift. They're in the town of Den Helder on the coast of the Netherlands, about to travel 150 kilometers over the frigid waters of the North Sea to work on the Noble Pete oil rig. And you thought you had a tough commute. Rig workers have to wear state-of-the-art survival suits that retain body heat. A helicopter crash in winter would send them plunging into near-freezing water. Unprotected, they would be unconscious within 30 minutes and dead within an hour. Helicopter accidents, though rare, are an occupational hazard. In the last 20 years, more than 60 rig workers have died when their choppers crashed into the North Sea. It's a hard fact to stomach, and they've got plenty of time to think about it. The ride takes over an hour. But as the rig appears, like an island in the middle of the sea, thoughts turn to the hard work ahead. The Noble Pete is about to start a new mission, drilling to tap a reservoir of natural gas worth almost $350 million. This oil rig is a specialized petroleum predator, perfectly adapted for its mission, to travel the oceans of the world and drill for precious oil and gas deposits buried miles below the sea floor. It's not like a ship. It has a 100-meter retractable leg at each corner. When it reaches a destination where petroleum is likely to be found, powerful motors drive these legs down through the water and deep into the sea floor, anchoring the rig in position. Standing on 3 legs like a tripod makes the rig so stable it can drill even during a North Sea storm. And that's vital, because on the Noble Pete, it's all about the drill. Housed in a 45-meter tower known as a derrick, the drill digs a shaft to pockets of oil and gas trapped in layers of rock. But the drill needs everything else on the rig to support its work. Up to 80 people are needed to run the operation, so there are 4 floors of living quarters. Below that, the steel hull is crammed with equipment, including 6 1,200-horsepower diesel engines that generate the juice to keep the drill running and the lights on 24/7. The operation costs over $55,000 a day to run, so anytime the drill stops, they're hemorrhaging cash. That's why the rig and its workers are pushed to their limits. Workers put in grueling 12-hour shifts for 2 weeks straight. Then they are helicoptered off the rig for 2 weeks of R&R. Every job here holds hidden dangers. Crushed hands, broken bones, and even death. The risks are high, but so is the money. Salaries up to $100,000 for 6 months' work. And that draws workers from all over. Lithuania, Malta, Portugal, Norway, France. 9 countries in all. They earn every penny. Because this megastructure never stops working. But even if they strike the mother lode, it won't be enough. In fact, all the oil rigs working the oceans of the world, and there are more than 500 of them, can't satisfy global demand. So companies are racing to build more rigs as fast as possible. But building them calls for another kind of megastructure, the giant shipyards that can mass produce these maritime monsters. One such shipyard is in Southeast Asia, near the western end of Singapore. Called the Keppel Fells Pioneer Shipyard, it's building more mega oil rigs than anywhere else in the world. Some shipyards have just a few hundred workers, but here, 4,000 people report for work each day.
Hey, one man stand behind,
It's as big as 38 football fields. It stretches over 69 acres, and its only product, massive oil rigs. This gargantuan dry dock is as big as 24 Olympic swimming pools. Right now, this Singapore-based company, Keppel Fells, is building almost half of all the world's new oil rigs. To hang on to their market share, they've got a bold strategy.
During the good times, we try to build as many rigs as we can.
They know that when fuel prices skyrocket, they can sell as many of these babies as they can make. But they've got to build them fast before the market cools. A typical shipyard builds 1 or 2 rigs at a time. But this mega shipyard is designing, engineering and building an incredible 23 oil rigs at once. They cost between $130 and $450 million apiece, and the customers all want them yesterday. Multiply that by 23 rigs and you have literally billions of dollars worth of time and money pressure. One mistake that leads to disaster could cripple the company and delight their competitors. Shipyards from Mississippi to South Korea would love to snatch away Keppel Fells' business. They're the leader of the pack, so they have the most to lose. But this Singaporean company has an edge. More than 35 years of experience building rigs in tropical heat and humidity. Tropical heat also describes the way these rigs are made. When you're building 23 rigs at a fever pitch, any slip-up could shatter the production schedule. So the company has spent decades eliminating inefficiencies in their production methods.
We try to innovate our processes in construction and so on, so that we can build better, safer and cheaper.
And faster. To speed up the process, they first build the entire rig in space. Cyberspace, that is.
As you can see here,
The engineering team works with a state-of-the-art marine architecture program. This is the design for a new state-of-the-art oil rig. 69 meters long, with 158-meter legs and up to 5 decks of living quarters to house 112 men. It's one of an advanced, super-efficient new generation of rig. It will drill deeper and faster than the older rigs, but the design is still a work in progress. The engineering team is inspecting their plan for an area below the derrick, and they've just caught a mistake. A pipe is running where a door will bash into it. It would be disastrous if they actually built it this way. Here, they fix it with a simple click of a mouse. Once the team completes troubleshooting the design, computers will guide every phase of construction as they turn the design into a reality. That will take 18 months, if they manage to stay on their breakneck schedule. First, steel plates are cut to precise size and shape. Each cut is controlled by a computer, using data from the design software. The software also helps generate the shop drawings workers use at every step of the building. Constructing the rig is like putting together a jigsaw puzzle, except this puzzle is enormous. It's made from 25,000 pieces of steel, and 100 lives will depend on how well they fit together. Even with methods this efficient and 800 workers devoted to this one rig, it still takes 6 months to go from cutting individual steel plates to finishing huge sections of the rig. This section is a part of the hull where giant pumps will be housed. It's as big as a locomotive, 20 meters long and more than 55 tons. When huge sections of the rig are finished, they're moved to the dry dock, where they are stacked and welded one after another, until the rig starts to take on its final shape. So far, construction is on schedule, but next comes the hard, tricky part, navigating it out of the dry dock and into open water. And this megastructure is still half a year from being finished and joining the worldwide fleet that's desperately drilling for oil and gas. Back in the North Sea, the Noble Pete has been hired by a French gas company to drill a new well. But this time it must literally mount and drill through what's called a permanent platform. The permanent platform is the structure shown here, just to the right of the Noble Pete. These platforms are placed where scientists, using advanced instruments that can see deep into the earth, determine that large reserves of oil and gas are likely to be found. This platform already has a number of working wells connected to pipelines sending the fuel to shore. But now it needs a new well, and it can't drill one on its own. That's why it needs a drilling rig like the Noble Pete. Many rigs can't handle this job, but the Noble Pete can because it can actually raise itself more than 7 stories above the sea. Huge electric motors turn massive gears that literally lift the entire hull out of the water, jacking it up into the sky. Called jack-up rigs, they can position themselves over permanent platforms for drilling. It sounds easy, like jacking up a car, but lifting this massive rig is the equivalent of jacking up 7,000 cars, while balancing on stilts in the middle of the ocean. So Dutch barge engineer Paul Kroner has reason to be nervous. He's about to jack up the Noble Pete.
Stand by for jacking.
36 electric motors, 12 on each leg, slowly turn the giant steel gears. To avoid a jam, rig workers slather grease where the gears will climb. One stuck gear could halt this mission before it even starts. Gradually, the rig begins to lift. 60 tense minutes later, the rig reaches its apex 26 meters above the water. But it's still not ready to drill. The Pete's drilling derrick needs to be slid out over the top of the permanent platform on a huge movable arm. Then the drill can be sent through a hole in the platform and down into the seabed. It's up to the Dutch drilling expert, Dennis Sellen, to execute this move. He activates 4 massive pistons that slowly begin pushing the 840-ton arm out over the permanent platform. Each piston is powerful enough to move 6 bulldozers, so powerful in fact that they all must be closely monitored.
Yes, going all right?
Yeah, starboard side ready.
All 4 pistons must push together so the arm moves straight ahead. If one piston goes faster than the others, the arm would jump its track, bringing the operation to a dead halt. It takes more than an hour, but at last the arm is in position. And this megastructure is ready to drill a new well. But even though scientists have told them where to drill, grinding through miles of rock to find a reservoir of natural gas will take at least 8 weeks, if they can find it at all. And the crew of the Noble Pete will have to stay on high alert as they drill, because accidents and death threaten every rig worker in the North Sea. When this megastructure oil rig in the North Sea isn't drilling, it's losing $55,000 a day. But even though it's in position to drill, drilling hasn't begun yet. That's because the Noble Pete's roughnecks, the workers who actually man the drill, must still haul more than 500 lengths of pipe from the main deck up to the derrick. This drilling pipe will get shoved into the earth a piece at a time for miles. Each section is 10 meters long and weighs almost half a ton. So this is a big job. It takes a winch and plenty of roughneck muscle to haul these pipes up into the derrick and onto the drill floor where the drilling takes place. The drill floor is one of the most dangerous places aboard a rig, and it's drilling chief Tony Wiltshire's job to make sure that everyone stays alert and safe.
Make sure that this valve is okay, because it's a safety valve we might need it in case of emergency.
Here, a careless worker could find himself on the wrong end of a swinging pipe. Though Tony's concerned about safety, he's also worried about speed.
In drilling, you always talk about economics. How faster it goes, how better it is.
To work more efficiently, the roughnecks join 3 pipe segments together ahead of time and stack them in the corner of the drill floor. Once they've stacked them all, they're finally ready to drill. Now it's time for this rig to start making money. They hope. There's no guarantee that this well will strike any oil or gas. In fact, in remote areas, half of all drilled wells strike nothing at all. To improve his odds, Tony's assembled a very experienced crew of roughnecks, led by Maltese driller Noel Shembry. But Tony's team has their work cut out for them. The client, Gaz de France, thinks they've located a new reservoir of natural gas almost 3 miles beneath the sea floor. But to get to it, the crew will have to drill at an angle through 40 layers of rock. By adding or removing weight from the drill pipe, Noel can control the direction of the drill bit. Under such immense weight, even steel pipe becomes flexible. But Noel needs to be careful, because the rock is littered with high-pressure pockets of seawater. If the drill nicks one, the high-pressure water could flood back up the hole with such force that it could destroy the well or even damage the rig itself. So Noel will have to thread the drill between these pockets like a needle. A needle that's miles away that he can't see. He has to trust his instruments and his equipment. A $30,000 diamond-tipped drill bit and a 1,000 horsepower engine capable of rotating almost 700 tons of pipe. Noel sends the drill bit down the hole to the ocean floor. Soon it will start to chip away at the rock below, burrowing a shaft towards the gas reservoir. When one length of the pipe has been pushed down the hole, the roughnecks connect another. This process continues until, hopefully, they hit their target. It will take at least 8 weeks, if everything goes right. And the driller needs to keep a vigilant watch over his gauges the entire time. A pressure drop or change in drill speed could indicate impending disaster, a cave-in. During a cave-in, the walls of the hole collapse, destroying the well and trapping the drill bit thousands of meters below the surface. But drillers have an unlikely secret weapon to defend against cave-ins: mud. On the drill floor, mud is everywhere. But this mud has no dirt in it, and it doesn't come from the sea floor. It's actually a sophisticated blend of chemicals pumped into the well to lubricate and cool the drill bit. The mud also performs another function. Its weight pushes out against the walls of the hole, helping to prevent cave-ins. Every type of rock that the drill passes through may need a different mixture of mud. Use the wrong blend and you could ruin a drill bit or destroy the well itself. So mud engineer Matthew Schofield can't afford mistakes. In his lab, deep within the bowels of the rig's hull, Matthew tests and retests his mud mixture until he finds the perfect recipe. Then roughnecks churn out more than 500,000 litres of the stuff. That's enough to fill 6 swimming pools. Like the blood in your body, mud is pumped through an elaborate circulatory system in the oil rig. 3 giant pumps in the rig's hull first push the mud up to the drill floor, then down through the drill pipe. When it reaches the bottom of the well, it spurts out through openings in the drill bit, floods the hole, and starts back up again, carrying with it bits of drilled rock called cuttings. When the mud and cuttings get to the top of the well, they are transported to 3 machines that separate the cuttings from the mud. This high-tech mud is so expensive, almost every drop is reused. And current laws allow these cuttings to be dumped back into the sea. If they were using toxic oil-based mud, every bit of chipped rock would have to be shipped back to shore to avoid contamination of the environment. Energy companies used to dump these toxic rocks back into the sea, but now they're acting more responsibly. In fact, today around the world, only 5% of petroleum in the sea comes from oil exploration and extraction. The key to controlling pollution is having all parts of the mud system work together flawlessly. It's also the key to safety. If there's not enough mud in the well, when the drill actually hits natural gas, the explosive gas can rush up and ignite. It's every rig worker's nightmare. A blowout.
Right, so there she goes. Explosion and fire on the Piper platform.
In the summer of 1988, explosions ripped apart North Sea rig Piper Alpha and woke up the world to the dangers of offshore drilling. A gas leak set off the first explosion, which was so horrific there was no time for an orderly evacuation.
The platform is completely on fire from sea level to top. We have in fact
167 workers out of 225 were killed, mostly from toxic fumes. The official investigation found numerous violations of safety rules and led to many reforms. The Piper Alpha was the worst, but by no means the last, disaster aboard an oil rig. So today, on a rig like the Noble Pete, the workers participate in a seemingly endless series of safety drills.
Attention all personnel, this is a drill.
Today's simulation is that some scaffolding has collapsed. They've found one roughneck. He's been crushed. He's holding on to life by a thread.
Emergency control.
More people may have been injured, so they need to account for everyone on board. In the mess, driller Noel Shembry and assistant driller Paul Brehabus are responsible for making sure everyone is present.
Yes, this is live board number 2 speaking. We have 15 people present, including myself.
It's 7 p.m, so both the day and night crews are involved. The Noble Pete is ready for any emergency.
This is a drill.
With high-tech lifeboats that can brave fiery water, a speedboat to save men who fall overboard, and a rescue boat that just circles the rig 24 hours a day, waiting for catastrophe. This is just a drill, but they make it feel real. That way, if there's a real accident, they'll save precious minutes and maybe lives.
We have ordered a helicopter to come and pick you up, okay?
If they were really summoning a helicopter, it would take 45 minutes to get here and another 45 minutes to reach the nearest hospital in the Netherlands. That's not a comforting thought, but it's the reality of life on the rig. Safety is always the #1 concern, and not just in the North Sea, but in the Singapore shipyard too, where they're battling the elements to move a new rig. In the North Sea, 150 kilometers off the coast of the Netherlands, the mega oil rig Noble Pete is racing to drill for gas miles below the frigid waters. It's dangerous work. Meanwhile, in Southeast Asia, on the island nation of Singapore, workers at the vast Keppel Fell shipyard are building the newest generation of mega rigs under super tight deadlines. It too is dangerous work, because a shipyard is an accident waiting to happen. Workers perch perilously far above the ground. Welding torches spew ultraviolet rays that can sear an eyeball. Potentially lethal loads dangle overhead. To keep their workers from getting killed or injured, the shipyard devotes precious time to meetings where they pound safety messages into workers military style. The oil rig that's just been assembled in the dry dock is set to be towed out. It needs to be moved to a wharf a few hundred meters away, where workers will spend 6 months finishing it. But there's a problem. This rig is one of 3 mega rigs waiting to leave the dry dock. 2 other rigs are blocking it. One's a jackup, and the other's a type of rig called a semi-submersible. In theory, it should be a simple maneuver. Just flood the dry dock and float the rigs. Then open the gate and tow them out one by one. In reality, the maneuver will be anything but simple. The process is incredibly complex, and they've scheduled just 2 days to move all 3 rigs. Not only that, the whole operation is fraught with danger. The rigs are huge, and there's very little space between the vessels. But if they collide during the move, or hit the walls of the dry dock, it will be a disaster.
we have to be very careful because any damage to the vessel or to the dock will cost us millions of dollars.
The process of removing the rigs from the dry dock is called undocking. They're under a severe deadline to undock these rigs right away because dry dock space is the most precious real estate in the shipyard. To keep the rest of the operation on schedule, they need to clear this dry dock for the next round of rigs. But if they're not careful, undocking could pose a threat to the environment. Because work on the hulls has left the dry dock littered with grit made of copper and steel. It's a real mess. If they don't scoop it all up, this metallic debris could end up polluting the Singapore Strait. By late morning, the workers finish the cleanup. They raise a red flag to show they're ready and open a valve to let the water in. It looks like more of a trickle than a gusher. At this rate, it will take all night to fill the dry dock, and the clock is ticking. By the next morning, the water level inside the dry dock has reached only 21 feet. Not high enough. This unexpected delay is going to be costly, with a lot of waiting around on the clock. Lim Yu Seng, known as Captain Lim, is in charge of the undocking. Meeting the deadline is his responsibility, and he knows undockings are always risky.
It's not as easy as anybody could do it, you see. You need very special skill in order to maneuver it out without even her touching anything at all. We want her to move out very smoothly and gently.
But smoothly and gently will be too much to expect today. Lim's worried. The forecast is for wind and rain. If the storm hits, he'll have to call a halt to the undocking. And that could shred his tight schedule. 3 tugboats are standing by because the rigs have no engines to propel themselves out of the dry dock. Captain Lim gives the order to open the gate. Slowly, almost imperceptibly, the gate begins to lower. Finally, the tugs start towing, and the huge semi-submersible rig begins creeping toward open water. But Captain Lim's luck doesn't hold. The weather gods are against him. He makes a tough call. Close the gate.
In order to prevent the semi and the 2 rigs in front from any sudden movements, we have no choice but to close back the dock gate again. And we will only resume our operations when the weather is back to normal.
It takes 2 hours for the squall to die down. When it does, Captain Lim seizes the moment. He orders the tugs to haul the rig out into the harbour. This rig is so massive, even these powerful tugs need time to build up speed. Finally, the rig clears the gate. That's 1 down. But there are still 2 more to go, and now it's late in the day. They haul the second rig closer to the gate before the weather can change. Once again, Captain Lim gives the go-ahead. The rig starts moving. With luck, the wind will stay calm long enough. It does. The second rig clears the gate and makes it out into open water. But it's too late in the day to move the third rig. They'll have to wait until morning. The next day, the sea is rough and a strong wind is blowing. Captain Lim tries to put a positive spin on the situation.
Everything is going very smoothly except for the weather is a bit rough this morning.
He knows that he's behind schedule. He can't delay any longer. In spite of the wind, he gives the go-ahead for the gate to be opened. Then the tugs haul the rig toward its new home at the wharf, where Captain Lim hurries to guide it in. It's a tight squeeze.
Another 1 meter, be okay?
The rig finally docks. Now it will need to stand on its own 3 legs while it's being completed. But the jack-up system has never been tested. If it fails, it will be a major setback. The 36 jacking motors are started. For the first time ever, this jackup rises out of the water. The rig passes the test, but it's still not home free. It will take another 6 months of grueling work to finish construction. After more than 2 hair-raising days, Captain Lim can breathe easy. He has moved all 3 rigs. The dry dock is ready for its next job. In spite of some close calls, he's kept his rig safe and the production line moving. But in the North Sea, however, the Noble Pete's mission is about to grind to a screeching halt. Back in the North Sea, the drilling crew of the mega oil rig, the Noble Pete, has reached a depth of more than 3,000 meters below the sea floor. But now, something's going wrong. They've only drilled 24 meters in the last 12 hours. That's 150 meters less than they'd expected. They must have hit some kind of snag, but the instruments aren't showing any problems. The pressure in the well is stable and the drill bit's rotation is constant. So they have to look elsewhere for an explanation. The first things they check are bits of drilled rock coming up from the well. Examining them shows what type of rock layer the drill is grinding through at this moment. Seeing hard rock, like granite or marble, would explain the slow progress. But under close inspection, Tom Branges only sees salt. The drill should be grinding through the salt 8 times faster than it's going. Clearly, the problem is not in the material they're drilling through. This could be bad news. Drilling Chief Tony Wiltshire wonders if the problem could be an undrillable well.
But sometimes you have these wells, they don't want to be drilled. Sometimes the problems are so big, they can't be solved, and then it's not economically worth to do it, you know, that the profit afterwards will be nothing.
If this well proves undrillable, they will have wasted 40 days and over $2 million. Tony knows that the only way to find the problem is to haul out and check all 3,000 meters of drill pipe. This is the worst part of a roughneck's job. The pipe must be pulled up and each 30-meter section detached and stored in a corner of the drill floor. It's grueling, messy work. The drilling mud is everywhere. And one at a time, over 300 heavy pipe segments must come out of the sea. The job is just too big for the roughnecks to handle by themselves. That's why Carl Gregg is perched 45 meters up in the derrick.
Okay.
He's using a robotic arm to grasp the top of each pipe and place it safely in a rack. But coordinating the move of a 30-meter pipe is risky, especially when the men grappling with the bottom end look like ants. Carl can't even see these men directly. He's totally dependent on a video monitor and hand signals. Even with this communication, it's a dangerous lift. If Carl opens these pincers too early, the pipe could fall on an unsuspecting worker. It takes 8 hours to remove all the pipes from the hole. A massive effort that will be a total waste if Tony's inspection fails to reveal the problem. But when the last pipe finally emerges, it's immediately clear what's been slowing their progress. A mangled drill bit. Inspection reveals that several of the diamond tip points broke off during drilling. Spinning loose inside the well, these ultra-hard diamond tips ground into the drill bit, causing extensive damage.
A lot of cutters lost, you know. Here, there. All these cutters being lost.
The roughnecks grab another drill bit, one they hope will hold up, and attach it to the first pipe. Now they send the new bit back down into the hole, reconnecting all 300 pipes, one by one. It will take another 8 hours before the drill reaches the bottom. This should get the drilling moving forward again, but they've lost precious time. It's been an exhausting day for assistant driller Paul Brehavus. When things aren't going well on the drill floor, roughnecks end up working twice as hard, and Paul spent 8 of the last 12 hours hauling out drill pipe. But at last his shift is over. If you work 12 hours and sleep 8, there's not much time left over for anything else. And if you're sweaty and grimy, your life's on hold till you get cleaned up. When you're as tired as Paul, an oil rig can seem like the world's biggest stairmaster.
Here's my apartment.
Like almost everyone on board, Paul shares a cramped cabin. But cabin mates rarely see each other. Paul works the day shift, his cabin mate works nights.
Thank you.
At mealtimes, people often don't have energy to talk. But at least the food's not bad. After dinner, the roughnecks try as best they can to unwind. But here, it's tough to forget about the job. Inside, it's claustrophobic. Everywhere you go, there's a reminder that you're still at work. Even out on deck, a homesick roughneck can only stare at the ocean and hope that the time passes quickly. So workers relax as best they can. Hitting the gym. Hanging out with friends. Even watching a G-rated kids movie. Over time, the workers become like family. And like most families, there's only so much togetherness they can take.
After 2 weeks, we are very glad we don't see each other for 2 weeks anymore.
But there's a payoff. These 2 weeks of grueling work allow them to have 2 weeks of uninterrupted home time.
I see my children go to school and that sort of things. And that's important for me. Not just weekends, huh? It's I'm 2 weeks off, but then after that I'm 2 weeks full-time daddy. And that's very nice.
For the workers, it's a constant trade-off between great rewards and great risk. After all, 3 spindly legs are the only thing protecting them from the frigid waters of the North Sea. On an oil rig, nothing is as important as the legs. The rig Alexander Keeland proved that when it collapsed in a North Sea storm in 1980. 123 workers died. The cause? A cracked leg. A single faulty part of a leg can lead to disaster. But it's a huge challenge to design and construct a leg that's tough enough to take extreme weather conditions. That's the problem facing the engineers at the Singapore shipyard. Senior engineer Chia Meng Kyong is testing his leg design for a new harsh environment rig. He batters the leg with violent virtual storms. As forces on the legs increase and decrease, the image changes color. Red indicates the strongest stresses. When he analyzes exactly where the stresses are worst, he will redesign that part of the leg to strengthen it. This newly built leg section stands ready to be transported to its oil rig, which has just been undocked. It towers 34 meters high and weighs as much as 35 bull elephants. How do they move a structure this tall and this heavy to the rig? None of the shipyard cranes can handle the job, so they call in Hercules. Asian Hercules 2, that is. A 125-meter tall floating crane, one of the largest in the world. It's so powerful, it could lift more than a dozen leg sections at once. But attaching the leg section to the crane is a huge job in itself. So they call in the Spider-Men. Workers use harnesses or scaffolding for protection when they're high above the ground. But these men are specially trained and climb the 30-meter ladder freely. Once they reach the platform high above the shipyard, the Spider-Men wrangle thick cables hanging from the crane and shackle them to each corner of the leg. Then it's back down to terra firma. And we have liftoff. Dangling from the monster crane, the 34-meter leg section looks like a child's toy. As the crane approaches, a crew on board the oil rig rushes to prepare for the new leg section. Finally, contact, and the workers align the new leg section with the old. Now the two must be attached permanently with invulnerable welds. In the coming weeks, they'll keep adding sections until the legs tower 130 meters into the air. That's almost as tall as the Great Pyramid in Egypt. But it will take a lot more than just adding leg sections to finish this rig, and the deadline is looming. At the shipyard in Singapore, there's only 5 months left till the deadline. The main deck of the new rig is a mess of steel and scaffolding, and below, crucial equipment and supplies have yet to be installed. There's a crushing amount of work to do, and there's a rookie in charge. This is Brian Lowe's first stint as project superintendent.
Careful, start with the outside first.
The superintendent has to oversee all the workers
You have one man to watch out for any flag.
and make sure they get the rig completed in time. While in the dry dock, a workforce of more than 800 people was dedicated to this one rig. But the superintendent has been given only 300 workers to complete the job, and he's anxious about it.
We got to push our people. Our operation is 24 hours, you see, so sometimes our men are working late, we have night shift coming in. So, to be honest, I'm a bit worried as well, even during my sleep.
Managing a job this massive is nerve-wracking under the best conditions. Brian has to be everywhere at once.
Okay, just hold on. So later I'll call Wilson Fong. You teach our people how to open the air temper, then you can run the engine. Just park the area.
And he's not sure his workers have enough time between now and the deadline to do everything. Like transform this raw steel box into a seagoing hotel for 122 people, and finish the mess room, which must feed more than 50 hungry rig workers at a time, with a kitchen worthy of a fine restaurant. And then there's the drill floor. It's still just a skeleton with the drilling machinery dangling in an empty derrick. But as long as there's oil down there, the frantic pace will not let up. Back in the North Sea, on the Noble Pete oil rig, the drilling continues. The drill bit is now turning more than 3,500 meters beneath the rig, and the work has reached another critical point. The bit is nearing 2 pockets of extremely high-pressure salt water. If they pierce one, salt water will shoot up the hole, possibly destroying the well and exploding up at the rig. Noel Shenbury has to guide his drill between these 2 danger zones. By adding or removing weight from the drill pipe, he can steer the drill bit at the bottom of the hole and change its course. But when the drill is more than 3 kilometers away, he's essentially navigating in the dark. His only guidance comes from a probe near the bit that transmits its location and direction. But suddenly, Noel loses the probe signal. It flatlines.
Yeah, we're getting nothing down here at the moment, so...
Noel's team has no way to know how close the drill is to the dangerous high-pressure pockets. So they immediately halt drilling. They run tests, hoping that it's just a computer glitch. But there's still no signal.
You can see the pressure, when the pressure is going down. Yeah.
So the trouble isn't the software. It's the probe at the bottom of the hole 3,500 meters away.
It's the tool that's not reacting.
Incredibly, they have to haul the pipe back up out of the well, all 400 lengths, for the second time in 3 days. 8 long hours later, the last pipe, which holds the probe, surfaces. But the $700,000 probe is stuck inside. It's high-tech equipment, so they try to be gentle. But the probe won't budge. So they have no choice but to get serious with it.
Just put tension on it. Right.
Finally, it's out, but there's no time to fix it. Fortunately, there's a spare. 12 hours later, the drill, with a new probe, is back up and running at the bottom of the hole. And the probe is working. Its signal reveals that the drill is moving right between the danger zones, threading the needle perfectly.
So as long as we keep away from these two floating blocks, number 1 and number 2, we should actually carry on just to the perfect job there.
Yeah.
But they still have 300 meters to go before they reach their target. Luckily, the broken probe is their last obstacle. Several days later, the noble peat strikes a reservoir of natural gas. It will take up to 2 weeks to retract the drill pipe and replace it with a concrete lining. Then the well will be connected to a pipeline leading to shore. The Noble Pete's mission will be complete. And it will be jacked down off the permanent platform and towed to its next assignment, somewhere else in the harsh North Sea. Back in Singapore, after more than 2 years of constant deadline pressure, the new oil rig is finished on time and on budget. Its legs tower 150 meters above the water. Tugs are towing it out to sea. It's beginning a voyage to its first assignment off the western coast of Australia. When it gets there, it will jack up and go to work at a rate of up to $105,000 per day. But the Singapore shipyard can't rest, not for a moment, because the world's thirst for oil and gas only grows. And it's forcing shipyards to build ever tougher and more efficient megastructures of the deep.